Nintendo Switch. Let's see what's going on. Switch over to microscope. We're going to take a look at this port closely, because they had told me it was a port problem, but to be honest with you, it looks a little bit gunged up. Not seeing a lot there. I want to give this a bit of a cleaning real quick, just for safety's sake, just because there's something in there shorting stuff together. I don't want to apply power to it. Alright, let's do a little bit of crud in there, fiber, some sort. But I'm not afraid to stick power to it at this point. So, turn on our power supply. And let's see what it's doing. For 8.7, 0.07, interesting. Interesting. Huh. Alright. I'm not really sure based on that what's going on, but we'll take it apart and just enough to do some testing and go from there. Okay, real quickly, I did perform one more test while I was over there getting ready to disassemble. I hit the power button, and we did get a Nintendo Switch logo, and then it just dies because the battery's dead. So that very well could still be a port issue. So we're going to pretty much assume that it is, but we're going to do all of our normal testing that we normally do between now and then. Okay, we have the board out of the housing now. Connect our meter and switch you over to microscope, and we'll begin to do some testing. I did not do the partial housing test because we know it's trying to boot up, so I definitely want to just start doing some measurements and all over the board and see what is going on. I suspect it's actually the port, but we'll see. So we're going to start with the Pi 3 USB. This capacitor is Pi 3 USB here. One side will be ground, the other side should not. Now we're going to start checking the signal lines. The lines go into the chip. Now the ones that have two, one side will always be ground on the capacitor. So, but the ones with single lines going to should not be shorted to ground. Uh-oh, we have found a short. So this may not be a port issue. Okay, so we have one cap shorted on M92T36. Okay. Let's check everything else out, just to be sure we don't have additional problems. Okay, everything seems all right here. Check our indestructible fuse. Being indestructible as usual. That should be ground. None of the rest of these should be. Check it out. Okay, and that one should be ground. Check our BQ24193. Same deal. If it has two going to the chip, one side will be ground. If it has one, you don't want that side to be grounded. Some of these had 2, but I know which side to check now, so I just generally just check the side I need to check. Let's pivot over and take a look at our Pi 3 USB. We definitely have an M92 T36 issue. And check our filters first. Okay, we want these to be continuous straight through, but not side to side. If they are shorted side to side, they will be bad. Alright. Find ourselves a ground. And our Pi 3 USB-C 5. So we do appear to have an M92 T36 issue. The question is, do we have an M92 T36 issue and a port issue? I don't think anything really looks wrong with this port other than it had a little bit of gunge in it. And nothing else is shorting to ground. So we're going to assume that we just have an M92 T36 issue. And that's not entirely odd. The system did try to boot up. The battery was dead. So, and typically with an M92 T36 issue or a BQ24-193 issue, the system will still boot up. It will not, however, boot up if you have a Pi 3 USB issue, typically. But we'll find out. This could be a port and an M92, or it could just be an M92. But we're going to remove this M92 and make sure our short gets relieved before making any more assumptions. It should, because like I said, it did try to boot. So I'm fairly optimistic here. But let's get to it. Before we actually get to it, I got to set up my equipment, and before I do that, I want to show you the temperatures that I expect to use on this job. They are always subject to change if something comes up, as far as airspeed and stuff like that. But I am optimistic that we will not have to change them. Alright, switch you back to scope. Sorry, we're getting a little bit of glare off that heat sink, but so I'm probably going to zoom you in a little bit. Alright, let's remove our chip. Okay, we had a little bit of a nudge. Things happen. Alright, we're going to check and make sure we've removed our short. Right on ground. No more short. Very good. Alright, we're going to put a new chip on. And go from there. Okay, I'll do a more in-depth cleaning shortly, but I just want to do a quick test and see if we're getting any different behavior. Than what we were. That's not much. Still may have a port issue. Grab a battery. Make sure we're not having a flakiness issue. No, we're still having an issue. Okay. Test around our M92 again, see if something blew again. Yep, still no shorts. That's good. I think we are going to remove this port. Okay, for that we'll do what we always do. We'll flood with low melt and go from there. Okay, that looks, our pole looks good. Put it aside. Make sure we have no bridges. No bridges. Not that it matters, we've done our testing already, but we did not have any more shorts, so all we really need to do is flip the board around. No, I'm sorry, I guess apparently I had you on the wrong screen. My bad. We'll flip the board around, put a new port on. Go from there. I'm going to do some quick probing because I had a little nudge incident when I was putting the probe on, the port on. So I just want to make sure nothing is shorted that shouldn't be. Okay. Nothing appears to be shorted. That's good. Alright. We'll do some more in-depth cleaning up in a bit, but I just want to do a quick test and see if we're getting any different behavior than what we were getting before with the old port. Well, that looks exactly the same. Exactly the same. How odd. Try the battery again. This one could be interesting. Oh, now it's charging. Now it's booting. Okay. Flip it around. Yeah, now it's fast charging and booting. So, okay. It was just being a little bit laggy about being activated. Okay. Being a bit flaky. Well, Nintendo Switches can be. Alright, so I'm going to clean this off a little bit more off screen. And then I'm going to put it back in the housing enough to test. And we'll go from there. Okay, we're prepared to do a test with my battery. Let's see what happens. It has a charge on it, so we know theirs is dead. Full battery symbol, that's good. Like you see it boot up without any errors. And it has. Very good. That's good. So I'll power down, I'll reassemble, and then let it charge on its own battery for a while, and then we'll perform our plethora of tests that we normally perform, just to make sure everything's good, and go from there. Just to be sure it is charging on both sides. Go from there. Okay, as you can see, we're back up and running on its battery. I'm going to plug their Joy-Cons in and do some testing. There, baby. Good grief. A little bit rough. Well used. Okay. We are recognizing and charging the Joy-Cons. Let's go do our internet test. Make sure we're picking up our networks. This always confuses me because Nintendo Switch is opposite from Xbox. Alright, we're picking up our networks. Alright. I'm going to let it charge a little bit more. We're up to 15%, but I'm going to set up for dock test and then we'll perform a dock test. Make sure our dock replacement went well and we don't have any other problems. And we'll come back. Okay, as you can see, it's docking up there on the top left. We'll switch you to capture. I think that's pretty much going to be it for this repair. Okay, in summary, we had one that was kind of pulling kind of weird amperage. It was like 0.01, 0.03, something like that, 0.07. So really didn't give me a great indication of what the problem would be. We took it apart entirely because I wanted to test the whole board just right away. I didn't want to do a test, but in the process of taking it apart, I did hit the power button just to see what would happen. It did attempt to boot up, though their battery was stone cold dead. So that gave me some encouragement that it might just be the port. However, once we went in there and started probing around, we found a shorted cap on M92T36. So it was definitely faulty. The Nintendo Switch will boot with a faulty M92T36 typically, so you just won't get correct charging. It will also boot with a faulty BQ24193 typically. You'll usually get false charging in that case, but it won't boot typically with a faulty Pi 3 USB, just so you're aware. So we had a faulty M92T36. We changed it out. The short was cleared, or we pulled it. The short was cleared. We put a new one on. Everything checked out. However, we still were getting about the same behavior as we were getting before, so that led me to the port. We're kind of lucky there that we didn't end up blowing another chip. If the port is faulty, that can cause you some issues. I'm not really sure what was faulty in the port. You couldn't really tell visually, but it was clearly faulty. So we pulled the port, put a new one on, tested again. At first didn't get the results we were looking for, plugged the battery to it, and it came back to life there. And since it has been working fine and has passed all the tests that normally performed for no power issue. That's really it. If you have any questions about the equipment I use in this video, take a look in the description below. They're all linked down there. If you like this video, do me a favor, hit the like button on your way out. And if you want to see more videos like it, hit the subscribe button and the notification bell, and you'll know when I post new videos. It's usually about twice a week at this point. If you have any questions, please feel free to post them in the comments, and I'll do my best to answer them. And that's really all I have to ask of you right now. Appreciate you watching, and we'll see you next time.